Do some guided practice for how to do nuclear equations. All right, so here we go. Number one, the first thing I want you to do is don't get overwhelmed by what you're looking at. We want to focus on the numbers and the numbers only. So I'm going to start with my numbers on top. I have 238. I'm going to make this look like a math problem, right? So the arrow is going to turn into an equal sign. So I have 238 equals 234 plus blank, right? So I need to know what number, when I add it to 234, will give me 238. So in order to do that, I need to subtract 234 from each side. So minus 234 minus 234. So 238 minus 234 is going to give you a 4. So up top over here is going to be a 4. So my top number for my answer will be a 4. Now we're going to do the same thing to my bottom numbers. So I have 92. The arrow means equals 90 plus blank, right? So I need to find my blank. So subtract 90 from each side, and you get the number 2. So the number on bottom is 2. Now, if you remember isotopes, then you'll remember that the number on bottom is the atomic number. So the bottom number here becomes the top number on your periodic table. So I look at the periodic table for atomic number 2, which is helium. So I write the symbol He. And since a helium atom was released, then my type over here is going to be alpha. I'll put my symbols here real quick. He. This can be a 0 minus 1 E, or you're also going to see this as the beta symbol. And then gamma is my little fancy Y. All right. Moving on to my next one. So again, focus on the numbers only. So I have 14 equals 14 plus blank. I subtract 14 from each side. 14 minus 14 gives me 0. So my top number is going to be 0. Look at the bottom numbers. 6 equals 7 plus blank, right? Minus 7 from each side. 6 minus 7 gives me a negative 1. You can also look at 7 minus 1 would give you 6, right? Minus 1. So then what symbol, right? Because there are no negative numbers on our periodic table, but what is negative in the atom would be an electron, right? So this is beta, right? Up here you saw it, negative 1, 0. You may need to write these down for yourself, but also the alpha and beta symbols are on your periodic table, okay? They're under your constants and conversions, and they're right here above the standard temperature and pressure. You have your alpha and you have your beta. So they're there for you on test day. Let's move down to our next question. All right, start with our numbers up top. We have 9 equals 9 plus blank. So you can subtract 9 from each side, or you can do 9 plus what gives me 9? That's a 0. 0 up top. In the bottom, we have 4 equals 4 plus blank. So what plus 4 gives me 4? 0, right? Or again, you can subtract 4 from each side. 4 minus 4 would give you 0. So some people are going to be able to just look at it and get it right off the bat. Others are going to need to do the math and subtract, and that's totally fine. Whatever is easiest for you. I have a 0 and a 0 on each side, right? 0, 0 means that I have a gamma. Remember, gamma radiation changes absolutely nothing about the element that we started with. So the atom that we started with is the exact same atom. We just release some energy in the form of light. And gamma happens after an alpha or beta radiation. All right, 2 more to go. We have 198. Arrow means equals 4 plus blank. So this one's a little bit different. They already gave you the particle. So we're going to have to find the element that this turns into after this type of radiation. So this one might be a little bit easier. If we just go ahead to get rid of the 4, we're going to subtract 4 from each side. So 198 minus 4 is going to give you 194. So our top number should be 194. All right, we're going to go ahead into our next problem. Not next problem, but the bottom numbers. And we get 86 equals 2 plus blank. Subtract 2 from each side. Those cancel out, right? 86 minus 2 gives me 84. So my bottom number is going to be 84. Now, this one you're going to need your periodic table for. Remember, the number on bottom becomes the number on top that we are looking for. So we're looking for an 84 over here on top. And here is the 84 on top. I cannot stress it enough. The bottom number here becomes the top number here. So the element that I'm looking for is PO. So this should be PO. And then what symbol did we notice in here? We have an HE, right? Helium being released is an alpha decay. All right. Last but not least, number on top is 61 equals 0 plus what? So what plus 0 gives me 61? That would be 61. Or again, you could go ahead and you can continue to subtract. So our top number will be 61. On bottom, we have 28 equals -1 plus blank. So in this sense, if you're not going to subtract, right, you can look at it as what minus 1 gives me 28. Or this is a -1, so then we must do a +1 to each side to get rid of it. All right, so 28 plus 1 gives me 29. 29. Again, the bottom number determines the element that we're looking for. So I'm looking for an atomic number of 29. 29, Cu is my element. want that. So Cu. And again, we notice right here we have this symbol, and that is indicative of a beta decay. So, and that's it. That is how you balance nuclear equations. So now take this and do your